Hello friends and welcome to my embedded school. In this video, we will learn about the Schottky diode, a unique kind of diode. So, let's begin. What is the Schottky diode? A Schottky diode is a special type of semiconductor diode that has the ability to switch at very high speeds and has a very low forward voltage drop. It's also known as a hot carrier diode or a Schottky barrier diode. They are named after the German physicist Walter H. Schottky, who discovered them in the 1930s. Structure of Schottky diode. A Schottky diode is different from a normal p-n junction diode. Instead of using two semiconductors, a Schottky diode uses a metal and a semiconductor. The metal acts as the anode, and the n-type semiconductor acts as the cathode. The junction between the metal and the semiconductor is called a Schottky barrier, which is a potential energy barrier that prevents the flow of electrons from the metal to the semiconductor. The width of the Schottky barrier depends on the doping level of the semiconductor and the type of the metal. Some common types of n-type semiconductors, such as silicon, gallium arsenide, or germanium, act as cathodes, and some common types of metal, such as gold, silver, platinum, tungsten, molybdenum, and chromium, act as anodes in Schottky diodes. The symbol for Schottky diodes is based on the basic diode symbol, with an additional line across the cathode to indicate the metal semiconductor junction. The 3-lead package is also used in industry. In this 3-lead package, the cathode of two diodes is combined. Working principle of Schottky diode. Schottky diodes work on the principle of thermionic emission, which is the emission of electrons from a heated metal. When a forward voltage is applied to the diode, the electrons in the metal gain enough energy to overcome the Schottky barrier and move to the semiconductor, creating a forward current. When a reverse voltage is applied to the diode, the electrons in the semiconductor are pulled away from the metal, creating a depletion region near the junction. This region acts as a barrier for the reverse current, unless the reverse voltage exceeds the reverse breakdown voltage of the diode, which causes a large reverse current to flow. The VI characteristics of Schottky diodes are similar to those of conventional diodes, except that they have a lower forward voltage drop and a higher reverse leakage current. Difference between Schottky diode and silicon diode. There are some interesting features of the Schottky barrier. Compared to a p-n junction, it has a smaller potential barrier, which implies that less voltage is needed to cause the current to flow forward. A regular diode has a forward voltage loss of approximately 0.7 volts, but a Schottky diode typically has a forward voltage drop of 0.15 to 0.45 volts. This indicates that a Schottky diode is more efficient and wastes less power as heat. The region where there are no free charge carriers is called the depletion region of the Schottky barrier, and it is extremely thin. This indicates that, in comparison to a typical diode, the Schottky diode could switch from on to off relatively quickly. A typical diode can only switch at a few megahertz, whereas the switching speed of a Schottky diode can reach several gigahertz. The Schottky diode is hence perfect for high-frequency applications. Application of Schottky diode. Schottky diodes have many applications in electronics, such as in power supplies, voltage regulators, rectifiers, clippers, clamps, logic gates, RF mixers, and detectors. They are especially useful for high-frequency and low-voltage circuits, where they can reduce power loss and improve efficiency. In this video, we learned about Schottky diodes, which are metal semiconductor junction diodes that have a low forward voltage drop and a high switching speed. We saw the construction, symbol, working principle, and VI characteristics of Schottky diodes, and how they differ from conventional diodes. Schottky diodes have many advantages, such as high switching speed, low power loss, high current density, and good temperature stability. However, they also have some disadvantages, such as high reverse leakage current, low reverse breakdown voltage, and high noise. That's all for this video. I hope you learned something new today. If you liked this video, please give it a thumbs up and subscribe to my channel for more videos like this. Thank you for watching and see you next time.